Hello. If you teach software engineering, you probably already grapple with the challenge of grading each individual student fairly and objectively when they're working on team projects. Now, team projects are great for software engineering courses for introducing students to experiential problem-based learning while developing the technical and soft skills necessary to operate on a large-scale collaborative project. However, with those benefits of a collaborative team project come the challenge of evaluating each individual according to how they contributed to their team's product. In this video, I want to introduce you into some methods that I explored to help instructors fairly and objectively evaluate their students. But first, let's talk about what some of the alternatives are. One approach is to grade each project as a whole and assign each team member of that project the same grade. However, this isn't necessarily a fair approach because while some teams will evenly distribute the workload, not all do. In fact, social loafing often results in individuals not putting in as much effort to team projects as if they were doing a project by themselves. As a result, it's not uncommon for there to be an uneven distribution of the amount of work that goes into each project. Another approach is to depend on subjective assessment. Now, some instructors choose to use their own observations and personal judgments to grade each individual as part of a larger team and give them independent grades based off of our perceptions of how much that person contributed to the project. Others may use pure evaluations where each student is asked to rate each of their teammates to give some insights into what they think each individual contributed to the team. However, either of these approaches is inherently subjective and susceptible to implicit biases. And in fact, studies have even found that seasoned teachers can exhibit implicit biases. Also, the halo effect has been observed where assessment of someone's work may be unfairly influenced by unrelated characteristics. For example, if there's a student who I really like personally, I may even unintentionally inflate their grade because I want to see them do well. On the other hand, if there's someone who I don't like as much, I might be more critical of their work, even if their work was of just as good quality and quantity as another student. So concerns there's particular concerns about either of these approaches being particularly unfair to students from underrepresented demographics. But fortunately, there are some tools and practices commonly adopted in software engineering courses already that help capture students' contributions to their teams in a more objective manner. So let's look at them one by one.
Git is a very popular version control system that's already been adopted in many software engineering courses. Here you can see a Git repository, both in its file view and its command line. Now, Git already has a feature to describe in a log format what commits have already been made to this project. However, to really gather all of the metadata that I'm looking for, I created a Python script that I've provided along with this paper that can summarize that history in a CSV file where you can see each row includes metadata about a commit, including who it was that made that commit and the volume of that change. Another common tool adopted in software engineering courses are project management boards, which help you keep track of progress within your project. Here you can see an example Kanban board that is supported by GitHub projects. A Kanban board includes the functionality that's still going to be developed, as well as the status from to do, in progress, finally to done. Now, each card you'll see represents a user story. In other words, functionality that's described in the terms of what the user needs. However, in addition, each card also has additional information that can help us keep track of progress in the project as well as activities of single members on a project. So if we look at the metadata within a card, we can see team members who have been assigned to that project. And this can also support multiple people if people want to collaborate on the same functionality. In addition, you can customize labels that help you categorize aspects of each of these cards. In my class, I instructed students to assign user story points to each card that they're working on. Now, points are to represent how much work they predict is involved in actually developing that functionality so they can deliver it to the user. This way, by the end of the semester, we can look and see not only what functionality is done, but we can identify using these emoticons who has actually been contributing to each one of these, and when they were planning out the project, how difficult they thought each of those stories were.
So after adopting each of these practices in a semester of software engineering class, I performed post hoc analysis after all of the grading was done to look at if these practices would help us give us more objective or fair assessments of each individual student's contributions and see what relationship these numbers have with those traditional assessments that depend more on subjective perceptions of someone's contributions.
First, let's look at students' evaluations of each other. We performed peer evaluations where each student rated their teammates on their interaction as well as the contributions they made to their team. As you can see, there is a strong positive correlation in between the two qualities, and overall, most students received fairly high grades. It might be noteworthy that only 3 students received a below a 3 on their contributions to the team. But let's look at the evidence to see if it justifies these high marks. Based on the metadata that we got from the Git logs, I looked at the number of commits that each individual member of a team made. Then I took that number and compared it to the total number of commits made within that team and normalized it to account for the number of team members in that team. Since each team committed a different number of absolute number of times, we're looking at 1 on this scale, representing what you would expect an average team member would do if they were committing their even share and each team member committing the same number of times. As you can see, there were some teams that had some balance, but it was fairly common to have quite a discrepancy in between the number of commits each team member made to the project. From that Git log metadata, I also looked at the number of line changes. Now that includes the additions and deletions made by each commit, made by each person. Again, this is relative to the total number of line changes for the whole team, since each team was working on a different project and in different languages often, but also normalized for the number of students on that team. We can still see some teams that did a little bit better than others, but some who definitely had outliers who contributed even more than quadruple what their fair share of the project was, while several of the students obviously did not commit nearly as much within those line changes. Next, I look at each project's Kanban boards and examined how many user stories that were completed were assigned to each individual member on the team. Again, I adjusted these relative to each individual projects, and unfortunately, as you can see, some of the teams didn't record enough of the data and follow the directions to assign themselves and label the points accordingly. Finally, I looked at the number of points of each user story that had been completed and which members contributed to those user stories. Again, this is held relative to the total number of points that that team accomplished over the course of the semester, as well as how many team members there were for that project. After looking at these more objective measurements of students' contributions, we determined that those peer evaluations were not particularly accurate representations of the actual contributions that each team member made to their team. In fact, that could be interpreted as a halo effect of students being artificially a little on the nice side when rating their peers. To investigate possible relationships between any of these variables and the instructor subjective evaluation, I looked at the instructor's grades for each student and found that the only variable that was a significant predictor of the instructor assessment was, in fact, the peer evaluation of the individual's contribution with this linear regression equation. Overall, these measurements seem to indicate some level of objectivity and independence from the subjective assessments, either by peers or by the instructor. However, there's still some limitations to this study. First of all, it really emphasizes quantity of work over the quality of contributions. Similarly, it only looked at the cumulative total of these measurements and not the frequency of those contributions over time. You might imagine that the best team members might be people who you can rely upon making regular contributions over a period of time, rather than trying to lump all of their contributions in at the end of a project. And while there isn't quite as much room for abuse, or it's not quite as easy to manipulate these measurements as it is for, say, peer evaluation, there is some potential for abuse or unexpected outcomes if you relied on these measurements alone to assess students. Overall, I see some promise in these measurements in being more objective and fair in assessing students. However, because of these limitations, it's probably too early to depend entirely upon these type of measurements. Instead, what I would recommend is to keep an eye on these and really investigate where your personal subjective insights and peer evaluations are not compatible with the evidence of someone's actual contributions. There seems to be promise in adopting these kind of measurements for assessing individual contributions to team projects. However, more work is needed in studying them and adopting tools to help us grade students fairly and objectively.
If you're interested in finding out some more of the fine details of this study, please read the paper that I've published at SIGSE 2020. I'm also happy to share with you my thoughts or answer any questions if you reach out to the provided email. And also keep in mind that I've provided the script that's posted up on GitHub in case you want to use my script to help you in your analysis. Thank you.